Let's continue on the topic of linear equation in two variables. Last time we discussed graphing. Today we're going to talk about given certain information, can we write the equation of a line? First case is if you're given the slope and the y-intercept. And if you remember last time, I said that if you have, for example, the y-intercept, the point when you cross the y-axis, for example, that point, and the slope, if you're given something like 3, then you can graph the line. Then you'll say 1 unit right. Sorry about that. We'll say I'll move 1 unit right, 3 unit up. That next point is going to be on the line as well. So I'll draw a line passing through that. This line has the property that has a slope of 3. And what I know is that this is the y-intercept. So if you're given the y-intercept and the slope, you should be able to find the equation of the line. And if you remember, there was a format for y-intercept form, y equals mx plus b. This is the y-intercept form of a linear equation on two variables. So if you want to find the equation of a line with the given y-intercept and the slope m, then this is the equation. So the y-intercept is the point 0 for x and b, and the slope is given m. Let's try an example. For example, given the slope of a line as 3/4 and y-intercept as, sometimes I only give you the y value, but I'm going to write it as a point because y-intercept is supposed to be a point. The x-coordinate is 0, but the y-coordinate is a number. Let's say -1. Find the equation of the line. Equation of the line. So in this case, what is given is the information, and what they want is the equation of the line. You want to figure out what is the equation. What you do is, you know the format for the equation. You're given the m, the slope is 3/4, and y-intercept is given as 0 and -1. So what do I know about b? B is -1, the corresponding y value. So how does the equation look like? Y equals mx plus b. You're already given m and b. So the equation would be y equals 3/4 x plus -1, which you can write it as -1. This is the equation of the line. Very easy. If you remember the slope y-intercept format. So this is the slope y-intercept format. And if they ask you to graph it, you don't really need to do much. You're given 1 point. The y-intercept is 1 point on the graph. 0 and -1. Let's say this is -1. That's one of the points on the line. And the slope tells you something information. 3/4 is the slope. This is rise over run. Or change in x, change in y divided by change in x. So that means move 4 units to the right. 1, 2, 3, 4. I'll end up at 4. And from -1 at this point, you stopped. Move up 3 units. 1, 2, 3. So where do I end up is at y equal to 2. Because I started from -1 and went up 3 units. At this point, 4 and 2 should be on the line as well. And that is the graph of the line. You can check to see if 4 and 2 belongs to the line. This is the point. How do you check? Replace it in the equation. It should satisfy the equation. 4 is for x, 2 is for y. You can try to check. This is a check. It's not necessary, but if you try it, just to make sure. 2 for y, 3/4 times x is 4 plus, -1. And what do you see is these two will cancel out. You have 3 minus 1 equal 2. which is a true statement. So this is correct, that 0.4 and 2 belongs to the line. And 0 and -1 also belongs to the line. Because if you replace 0 for x, you'll get 3/4 times 0 is 0 minus 1. Y becomes -1. Okay, I hope this is very clear because it's nothing too complicated. If you're given the slope and y-intercept, you should already be able to find the equation. There's other cases. There's another case that instead of giving you the slope and the y-intercept, what they give you is 2 points on the line. I mentioned if you're given 2 points, you always can find the slope. So if you're given 2 points, you remember the slope form is y2 minus y1 divided by x2 minus x1. This is if you're given 2 points, x1 and y1 and x2 and y2. This was our calculation toward the slope, definition of the slope. So what do? You have found the slope through the 2 given points. How do you find the equation? There is an equation, the standard form of the equation, if you remember. Y minus y1 equals m times x minus x1. This was the standard form of the linear equation. You can use this standard form. Because what do you have now? You already found the slope, and you already have a point, x1 and y1, and you already found the slope. So you replace those numbers and you have founded the equation already. Let me show you through an example. So here's an example. Given 2 points, given, let's pick 0, 1, and 2 and -4. Let me change it to -5. On a line, find the equation of that line. The equation of the line. Okay, so you have 2 points on the line. If you're given 2 points, you can always draw a unique line through those 2 points. So there is one line that goes through these 2 points. We want to find out the equation of that line. First information that we want to find is always the slope. What is the slope? You can call this y1, x2, y2. Then the slope becomes the difference in the y, so -5 minus 1 divided by difference in the x is 2 minus 0. And if you calculate, -6 divided by 2, -3. So found the slope. Slope is -3. So what is the equation? Use the standard form of the equation. In this case, you're already given the y-intercept, by the way. 0 and 1 is the y-intercept because x is 0, means where you cross the x-axis. But not always they give you the x-intercept. You could use the y-intercept form here because you're given the point that belongs to the that crosses the x-axis, the y-axis, the 0, 1. So that means you already have b. This is b. So the equation becomes y equals m, which is -3x, plus b, which is 1. This is using the slope-intercept form. You're already given b. But not always you have this possibility that the b is given. So I'm not going to use that, but I will show you later that you have the same equation. So this is what we expect at the end. Let's assume we don't know that 0 and 1 is the y-intercept. So what do? We go through the standard form. What is the standard form? Standard form says y minus y1 equals m times x minus x1. Use the standard form. Here, it doesn't need to be x1 and y1 the same thing. You can use the other point. You can use x2 and y2. It doesn't really matter. Let's try to use x1 and y1, in this case 0 and 1. So you would have y minus 1 equals m times x minus, m, we already found m. M is -3, x minus 0. So I replace the point x1 and y1 into the equation. And if you simplify, let me continue. and simplify. This is if they want it in standard form, you're done. This is the answer. If they want it in the y-intercept form, we have to simplify a bit more. Y minus 1, distribute the negative 3. In this case, times 0, it doesn't do anything. So you'll get negative 3x. Isolate the y, because y-intercept, y is isolated. Add 1 to both sides. So what do you get? Negative 3x plus 1. This is the y-intercept form as well. Same result that we had earlier. If you use the other point, if you use 2 and negative 5 instead of 0 and 1 into this equation, instead of 0 and 1, if you use 2 and negative 5, you're expected to get the same result. It's not going to give you a different equation. After you simplify it, you will end up with the same equation. Okay, and how do you graph it? You have 2 points. You do not need to use anything. Find those 2 points. Just graph the line passing through those two. Okay, here. The 2 points are given 0 and 1. As I said earlier, this is the y-intercept. 2 and negative 5. 1, 2, let's say negative 5 is somewhere here. The line that goes through those two. And you can think about, you can use the slope as well if you want, instead of using the 2 points. You can pick this point and move 1 unit right. Since slope is negative 3, you can always think about it as negative 3 divided by 1. That means if you move 1 unit to the right, you have to move 3 units down. 1, 2, 3. I'll end up on the line again. Be at negative 2. You move 1 unit to the right again, then 3 units down. 1, 2, 3. You'll end up at the other point, negative 5. And so on. It's not necessary to find a million points, just 2 points is enough to draw a straight line. Okay. So this is if you have 2 points, you can always do that. What if you're given 1 point in the slope? If you're given 1 point in the slope, then simply use the standard form, because you're given the slope and you're given a point. Okay. If you're given 2 points, then you have to figure out the slope. That's why we did this extra step. It's the more difficult one. Okay, so if you're given the slope and y-intercept, use the y-intercept form. If they're given the slope, if you're given 2 points, use the standard form. First find the slope, then use the point. And if you're given slope and 1 point, just use the standard form. But at the end, depending on what the question wants, if they want you to write it in standard form, that means isolate the y, move everything else to the other side and distribute and simplify. That's what we did here. This is the slope intercept form. Okay. How about writing an equation of a vertical and horizontal line through a given point? So last time we discussed equation of a vertical and horizontal line. And I think I already mentioned it, but maybe I wasn't so specific about it. So here is an example. Given a point, let's pick something. 1 and negative 2. Find the equation. Let me use it. Shorten it. Equation of a line, vertical line, passes through that point. That passes, maybe vertical and horizontal, both. Lines that passes through that point. Okay, so what do we want? You're given a point. The point is 1 and negative 2. 1, negative 2. I want to find two equations. One is the equation of this vertical line that passes through that point. And the other is the equation of this horizontal line that passes through that point. Okay, so first let's figure out the horizontal line. the horizontal line. One information that we already mentioned from last time, horizontal line has slope 0. You should remember that. But it's not very necessary to do this, to use the slope or anything, because horizontal and vertical line have a specific form. What does horizontal line look like? If you pick any point on the horizontal line, all these points, they have certain property. What is the property? They all have the same y value. What is that y value? -2 in this case. So the equation of the horizontal line, it doesn't depend on x at all. It's only the y value. X could be any number. It could be 3, 4, 5, and so on. -2, -1, all these numbers. Only depends on y. Y only has to be a fixed value, -2. Always. So what is the equation of that horizontal line? Y equals to -2. X can vary from any number that they want, from -infinity to +infinity. How about vertical line? Just to remind you of the property of the slope. Slope was undefined because we would divide by 0. And what do you expect from the equation? Let me use a different color actually. This blue line, any point that you pick on this line, they all have the same x value. X value is a fixed value, 1. So any x value, all the x values are fixed. The y values could be whatever number. All these numbers are possible. So it's only x that is restricted. X must be a specific value 1. So a horizontal line had the form of y equal to some constant. Vertical line had the form of x equal to some constant. And what are those two constants? Either x coordinate or y coordinate, depending on what they're looking for. If it's vertical line, it's the x coordinate. If it's horizontal line, it would be the y coordinate. Y equal to -2 would be a horizontal line. X equal to 1 would be a vertical line. You do not need to memorize. Just look at the graph and see, okay, what is the restricted value? X is restricted, so this is a vertical line. X is always 1. Okay. Now, the most important case here is talking about parallel and perpendicular line. There are certain properties about parallel and perpendicular. I'm going to show you the properties, then we will do examples. Here. Let me draw. Let's discuss the parallel line because it's the easiest one. Let's assume we have a straight line here. Some line like that. And you're given 2 points on this line. And if you're given the slope, let's say slope equal to 2. That means if I start from this point, move 1 unit right, I have to move 2 units up to get to the other point. To get to another point on the line. This triangle, if I can draw a straight line here, straight down. Sorry about that. This seems very easy to do, but for some reason, okay, here we go. This triangle that we have created, we moved 1 unit right, 2 units up, just to create this slope equal to 2. If you have a parallel line somewhere else, let's assume this is a parallel line, and you pick another point on this. Since it is parallel to that line, it should follow the same procedure because it should have the same triangle created by symmetry. If they're parallel, if you move 1 unit right, 2 units up, then these two triangles would be similar triangles. These lines will never intersect with each other. If the triangles do not form the same thing, you have some line here and another line. You want to create a line that goes with maybe steeper. Then the triangles that you create do not have the same shape. They may look alike, but this length, if this is 1, this is 1, and this height would be something like 0.5, the other one would be 1. They're not going to be equal because at some point they will intersect. If you continue. Okay, so if you have parallel lines, what you have is the two triangles that you create by moving along right and up or left or down all these triangles that you create by moving to create a slope, they must be similar triangles. It means that two parallel lines have to have the same slope. Same line anywhere else you draw, you expect the same triangle. One here, two up, same slope. So what can I say? I can say if I have two parallel lines, so let's say line 1 is parallel. I don't know if there is double R. I think it's 1R, right? Forgive me for making mistakes. Parallel line is parallel to line 2. To line number 2. If they both have the same slope. If they have the same slope. Same slope. Okay. You can prove this through the triangle. I don't want to create the proof. I just want to show you an idea of it. And sometimes they use this. They say line 1, line 2. They draw two parallel lines and say line 1 and line 2 are parallel. Therefore, slope correspond to line 1 equals to slope correspond to line 2. These are notations, so if you see, do not get confused. It's just they have this meaning. Okay, so parallel lines, they have the same slope. They do not have the same points, otherwise they would be on top of each other. So if I pick another line, it cannot cross here and be parallel. So they never have the same points. This line and these two lines, they never have the same points. They always have different points, unless they're both on top of each other. If that's the case, then you're discussing the same line. Okay, let's discuss the perpendicular line. Again, I'm going to pick an easy case so you can see it. Let's say if I have this straight line. Draw it maybe a bit tilted, just because that would be too specific. Let's say I have this straight line here. Let's say this has slope 3. 1 unit right, 1, 2, 3 unit up. This would be the triangle. Okay. If I want to draw a perpendicular line, let's assume it goes through the same point. It would have to create a 90-degree angle. Something like that. This angle should be 90 degree. It's not exactly 90 degree, but let's assume it's 90 degree. Okay, then now, what is the slope of this line? The question is, how does the slope of this line look like? It turns out that what you're doing is basically rotating. So this triangle rotates as well. So instead of going right 3 units and up, then you go left 3 units. This straight line that I drew is not very perpendicular, so it's not clear. So let me draw this maybe very precisely. This looks better at least. Okay, so it turns out that you have to move 3 units to the left and 1 unit up. 1 unit up, 3 units to the left. So now what happens to the slope? What is the slope of this line? The slope turns out to be now 1 divided by -3. Because of the rotation of the triangle would flip over. It will look like that. Because you're rotating 90 degrees this straight line. So what happens to the slope? The slope would be the reciprocal, but the opposite side. So if two lines are perpendicular, I'm going to write it this way. If line 1 is perpendicular to, this is the notation for perpendicular, to line 2, then the relation between the slopes is that slope 1 equals to -1 divided by slope the other one. It's the opposite and reciprocal. Or in some sense, sometimes they write it this way. They say if you multiply them together, you expect -1. This is just by some simplification. If you multiply both sides by m2, these two will cancel. And you would get that the product of the slopes is -1. And if you do it here as well, 3 times 1 over -3, what you get is -1. This is what it means. The product of the two slopes is -1. But the easiest way to think about it is the slopes are opposite and reciprocal. So here, let me erase this. This is a very common one that we use. M2 is the opposite and the reciprocal. Okay, so parallel line have the same slope, perpendicular line, they have opposite and reciprocal. Okay, so let's do an example. Let's do a general example. Find the line, find the equation of the parallel and perpendicular line. Lines to the line y equals 2x plus 3, and it passes through the same y-intercept. Sorry, that passes through, not the same y-intercept, that passes through the point. Let me pick a different point. Otherwise, the parallel lines would be the same. Through the point, I wanted to say it for perpendicular, but let's say differently. 1 and 1. Okay. So here, first some information to understand. I'm going to graph this line. Before we get into it, you're given the equation. You should be able to find the slope because it's in the slope form. Slope is 2. And what is the y-intercept? It is not 3. It is 0 and 3. Don't forget that. 0 and 3. So here, 1, 2, 3. This is one of the point. And slope is given 2. So I'll move 1 unit right, 2 unit up. That's another point. And I will connect these two. Something like that. Okay. So now this is the equation of this given line. This star. Call it star. You can call it line 1, line 2, whatever you want. Okay. Now what do we want? You're given a point. The point given is 1 and 1. Here is the point 1 and 1. And I want two things. One is to figure out the equation of the parallel line that passes through there. Okay. As well as the equation of the perpendicular line that passes through here. I want to find out this line as well. So let's try to find out. The easiest one is the parallel line. So I'm going to use color blue to solve the equation for the parallel line. Okay, so what is the slope of the parallel line? Since we know it should be parallel to the red line, they must have the same slope, 2. Do I have a point on that parallel line? Yes, there is a point given, 1 and 1. So what do? I use the equation of a line, y minus y1 equals m times x minus x1. This is the slope, the standard form of an equation. So y minus 1 equals 2 times x minus 1. If they want it in the slope-intercept form, I will simplify it and say y minus 1 equals 2x distributed 2 becomes -2. And add 1 to both sides. What do we get is y equals 2x. If you add 1 to both sides, you'll get -1. this is the equation of that blue line, the parallel line. Goes through the point 1 and 1, and it has the same slope. You see that they both have slope too. How about the green line? There's no difference actually in the calculation. The only difference is what is the slope. This is the problem. Since it's perpendicular to the red line, the slope must be opposite and reciprocal. So the opposite would be -1 divided by 2. This is reciprocal of 2 and also opposite, so negative. And is it given a point on the line? Yes, there is a point given, 1 and 1 again, the same point. And what do? We use the equation of a line, y minus y1 equals m times x minus x1. There is no difference. It's just the numbers have changed a bit. Instead of 2, now the slope is -1/2. X minus 1. I'm using the point, this is x1 and y1. The same here, x1, y1. And if you simplify, you'll get y minus, sorry about that. Y minus 1 equals, distribute the -1/2, -1/2 x times -1 becomes +1/2. Then add 1 to both sides, y equals -1/2 x, 1 plus 1/2 becomes 3/2. This is the equation of the green line. This is the equation of a perpendicular line to the red line. You can always check if you have two lines to see if they're perpendicular or not. Their slopes must be opposite and reciprocal of each other. This one has slope -1/2. The blue line has slope 2. These two must be opposite of each other, must be perpendicular to each other because they have the perpendicular slope form. One is 2, the other one is -1/2. And or you can say if I multiply them together, I will get -1. Okay, so this might be the difficult case, the most difficult one through the line equation, because you have to figure out the slopes through comparison. Okay, I'm gonna stop here.